Hi everybody, my name is Salman Khan and I hope you are all doing well. Today our topic is about current and future trends in IT. So in this lecture, we will discuss how IT is helping us currently and how it will help us in future. So let's discuss this in more detail. As we know, the work that we need to do is increasing day by day. And it's getting hard for human being to handle such increasing work and to take care of it in a small amount of time. So for that purpose, computers are here to help us all. Computer became so fast and strong during the time that it can handle even much bigger tasks in a very small amount of time. For example, if we are about to calculate the average of more than 10,000 or 1 lakh entries, it's going to be very hard to do it manually. But computer will do it in seconds. So computers are here to help us. By strong and fast, I mean, it is capable to do like large amount of computation, calculations, or predictions, everything. It can handle any task in seconds or minutes. But if someone is doing it manually, it will take a lot of time. So computers are faster now as a decade ago and can store a lot of data. A computer help us almost in every task, in every field of our life, like from small household tasks to office work and like big scientific research. Everywhere we are using computer nowadays for our assignments and whatnot. Everywhere you are using computer, even the mobile phone, which is kind of computer, we are using it. So we are using computer everywhere. But still, there are some cases where human think and perform much faster than computer. And what are those cases? So as we know that computer work when an instruction is given to it. Otherwise, it will be idle. It will do nothing. So it needs a human being input from a human being to operate. Computer can't make their own decisions. Human is required to operate it. I mean, to give it instruction, but when it's come to generate new idea, for example, for creating method to any solution, human mind is faster than a computer. A computer will do a task using a method which is already predefined by a human, but a human can generate new ideas very fast than computer. So in such cases, computer is lagging behind a human. Obviously its calculation is much faster than human, but still the ideas, the methods, and other stuff, human being is much faster than computer in such cases. So how to handle such issues? How to make computer think better and faster than human being? For that purpose, artificial intelligence, a field of computer science, was introduced as an attempt to help computer think and act similar to human being. So by artificial intelligence, what is the artificial intelligence goal? So the basic goal of artificial intelligence is to enable computer and machine to perform intellectual tasks such as problem solving, decision making, understanding human communication, and other more stuff. So as I have said before, that computer can solve a problem, but it can only solve those problems which the instructions are given. But now with artificial intelligence, computer will follow other method as well. Computer will perform in such a way so that it will use other method to solve a problem, and it will take its own decision now with the use of AI. And another use of AI is also to understand human communication. What human is trying to say to a computer, or what it's trying to communicate. Like, for example, for this understanding human communication, we have the example like how if someone is computer understand, for example, computer understand English language. And if there's a person who doesn't know how to speak or write English, he will use his native language, let's say Spanish or some other language like Chinese, but computer will translate it. AI product, AI softwares are there to translate it. And then it will be easy for it to communicate to computer. Now, what is AI? Artificial intelligence was introduced as an attempt to help computer think and act similar to human beings. The basic goal of AI is to enable computers and machines to perform intellectual tasks, such as I mentioned previously, problem solving, decision making, and understanding human communication. A broad field of computer science that focuses on developing intelligent machines that can do activities that would normally need human intelligence. Or in simple words, we can say that artificial intelligence is the intelligence demonstrated by machine as opposed to natural intelligence displayed by human. So now we will see what AI can do. What AI can do today, AI can help us in robotic vehicles. For example, I will give the example of a self-driving car. It also known as an autonomous vehicle, driverless car, or robotic car. It is a vehicle that is capable of sensing its environment and moving safely with little or no human input. I can give you another example of such vehicle. In car assembly, robots keep worker from exposure to fume from welding and painting, as well as weld flesh and the noise of stamping presses. Automotive robotics cut accident and injury claim by removing worker from these dirty and dangerous tasks and environment. So AI is helping us in such a dangerous field and in such a dangerous environment. Another thing is autonomous planning and scheduling. AI is also helping us to plan and schedule complex tasks. For example, the task of planning and scheduling the people working or the employees working at airport, and like, for example, you can say the air hostess or the pilots or the moving of planes around the world. All of these things are really hard to plan and schedule by a human being. By doing it manually, it will cause a lot of confusion and will take a lot of time, even months. So you just give input data to a software, and AI will help to plan and to schedule the timings of the plans and the employees, when they will work, when they will take leave. So these things, you just need to give simple instruction to the software, and all the planning and scheduling will be done by AI. Formal methods. Formal methods are techniques used to model complex systems as a mathematical entity. These methods are normally used to expose flaw in a system requirements, and it enables better understanding of the problem. So normally, if we want to understand the problem to any method, we are using formal methods, and AI is helping us a lot in this field as well. By formal methods, you mean model checking, that if the model that we created for AI by AI, is it working fine or not? What is the problem? So this is how AI is helping in formal methods. Machine translation. As you all know, that we are translating, as I mentioned previously as well, like if someone is coming to Sweden or to going to China, but he or she can just only speak English. So it's really hard for them to spend time in such a country where nobody speaks or understand English. So then you use some softwares which are translating what you are saying or what you are writing to a language which the other person can understand. So these are all done by AI. Speech recognition. This is another thing where AI is helping us a lot. So nowadays, if you see, if you can search, anything on Google without typing. There is a microphone, or you can see the microphone icon there. When you press it, you just talk, and it will automatically write what you are speaking. So they are understanding what you are saying, or they're converting your your words into a machine understanding instruction. So this is what AI is doing in speech recognition. Recommendation. As you see that not all of the emails coming to your mailbox are going to inbox. Some of them also goes to spam or junk folder. So this is done by AI by looking into some patterns in the email, that this is by classifying the email by looking into its content, that this an actual email, or this is a spam used by some hackers who want to hack you, sent to you. So if such emails AI found out, then it will send it to the spam folder or junk folder. But if it is fine, it is correct, then it will automatically go to the inbox. Game playing. Nowadays, you will see there are a lot of AI is using a role in gameplays a lot. For example, chess, Go, and other games where you play with AI. So it's really hard for you to win from such players, because AI is handling it. And yeah, there are a lot of games you can download it and you can play with the machine. But remember that that's like a really you're playing with a really intelligent machine at that time. So it's going to be really hard for you, but there are AIs playing to help you play with them. Image understanding. This is like a really important topic where AI is playing a big role. So image understanding, we are using it in medicine diagnosis, like for example, X-rays, or other kind of, if you can say, there is like kind of disease in cancer, like for example, if you took to the COVID recently, and they scan your whole body, so you can easily identify by looking at it, okay, the lungs of this person is really affected by the virus. So like if there are a lot of people, and manually for a single doctor, it's really hard for them to check it, each and every x-ray or scan report. So simply AI can understand, diagnose the pattern in the x-rays or the scan on the scan result, and it can conclude that, okay, this is the same pattern in all of the scans, which means all of these people are affected by COVID, but the one which has a different pattern, so this is not the COVID case. So we are using a lot of AI even in medical terms as well. Now we are looking at the examples of artificial intelligence. As I said, you speech recognition, we are having Siri, Alexa, and other smart assistant. Siri, everyone is aware of Siri and Alexa. Self-driving car, Google has developed a self-driving car where it needs no driver, and you just give it the instruction that I'm going to this. You just put in your destination in the application, and the car will take you from your place to a destination. So it's really smart cars. Still working is going on to make it more secure. So to leave them with the other cars, which are not smart cars, and to check them, like, okay, they are operating exactly the same way, where a driver is using the car. I mean, like, for example, the car which is not smart. So this is the example of AI. Robo-advisor, as I mentioned earlier here as well, that for car assembly, where in industries where, like, if you see there are a lot of videos of Tesla when they are making Tesla cars. So you can see there are like robots which are assembling the parts of the car rather than the human or the employees working there, just because these are really dangerous thing to do it manually. You can damage yourself by welding or by any other stuff. So these things are handled by robots. Conversational bots. So as everybody nowadays, it's really common everywhere. Chat booth is also called chat booth. It is an app that runs simple and repetitive automated tasks performed by the user, such as customer server or support stuff. Like, for example, normally nowadays when you go to a website, so there is a window, pop-up window, and it say, do you need any help, or just like, for example, and they will show you, okay, please wait for a while. Someone from someone from the customer service will be here soon. So such kind of chat booths are very common nowadays. So these are also the applications of AI. Again, email spam filter. This is the example of AI. Okay, so Netflix recommendation, YouTube recommendation, Spotify, these are all also done by AI by looking at your history, like what you liked or what you watched previously. So according to those data, according to your history, it find out some patterns. Okay, he liked the songs, he liked this song, and this is sang by this one singer, and they will try to search the same singer or such genre song. So it will recommend you. So it's like also done by AI. Now, definitions of AI, AI doesn't have any specific definition, but the most common, what we can say, that like the machine which is performing a task intelligently or like human, we call it AI. But here it's divided into 4 parts. We will go through it one by one now. The first one is thinking like humanly. So when a computer or when a machine thinks like humanly, so that is also called AI. The exciting news, effort to make computer things, machine with minds in full and literal sense. The activities that we associate with human thinking, activities such as decision making, problem solving, learning, these are all known as thinking human. These are all related to thinking humanly. Another one, thinking rationally. Rationality means like if there are options, a lot of options to solve a method, but there is the best one which is taking less time and which is more efficient, that is called thinking efficiently. So thinking humanly, but there are a lot of thoughts which are in human minds, but which one is the best one? The best one which will produce the best result, that is called thinking rationality. Acting humanly. Now we have a lot of things in our mind, but how a human perform on it now. So when a computer have a lot of thoughts as human do, and then it also act in the same way how a human should act, that is known as acting humanly. The art of creating machine that perform functions that require intelligence when performed by the people. This is given by the Kurzweil in 1990. Acting humanly and now acting rationally. So again, human can act in several ways, but one of the way, which is the best one, that is the rational one, right? So in choosing, I will summarize it in a sense like human thing, there are a lot of thoughts in human mind, but the best thought is the rational one, right? Now, after that, we are having a lot of thoughts and we need to act on it. So also, as I mentioned, when we are acting in the best way, that is known as acting rationally. So these are the definitions of artificial intelligence organized in 4 categories. So like at one side it's human and the other side it's rational. So thinking like humanly is also the part of AI. Thinking rationally is also the part of AI. So we will obviously in artificial intelligence, we will go always with the rationality, just because it is producing us the best results always. Now the conceptual picture, how things work in AI. So there are like two main important terms which you must know, and which are really important. You should be aware of it. So one is agent and one is the environment. Without these two, AI will do nothing. Now, what is agent and what is environment? We will look into this into more detail in the coming slides. But remember that AI is incomplete without agent or environment or both. So to make a perfect AI or to good artificial intelligence, for good artificial intelligence, agent and environment is must. Also, I would add here, like there's an agent and there is an environment of the agent. But remember, environment of the agent is just the surrounding of agent, not the agent itself. Agent observe the environment, right, by some kind of sensors, and then perform an action. Like agent saw something in the environment and now he needs to do something. So after sensing by using their sensors something in the environment, then agent will use its effectors to perform an action in the environment. Let's look into definition into more detail. Agent. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. What will agent is in the environment? Agent will sense something first and then it will take some kind of action through actuators. For example, vacuum cleaner. Let's say the vacuum cleaner is our agent, and now how it will work, we are going in the details now. But first first go to the environment definition. As we define agents, we need to define the other term as well, environment, as both are connected to each other and both depends on each other. An environment is everything in the world which surrounds the agent, but it is not the part of an agent itself. So everything apart from the agent is environment of the agent, but agent within, like agent is not environment. Everything surrounding it is environment, right? An environment can be described as a situation in which agent is present. We can also say that it's not important that it's like some kind of physical environment should be some kind of physical thing. No, it can also be a situation where the agent is. So remember that it's not just a physical thing. It can also be a situation or some kind of idea. The environment is where agent lives, operate, and provide the agent with something to sense and act upon it. As I said before, environment is where the agent lives, and it will do some kind of action by sensing something. Now, the environment here, for example, we get the example of a room environment. Let's take, we are having a room as an environment, and vacuum cleaner is our agent. So, and there are kind of actions that what is the task of the vacuum cleaner? To clean the room. So do nothing if the room is clean, otherwise clean it. These are the actions of the agent in the environment, which is our room. But how agent will clean it? First, agent need to check if there are dirts in the room, then clean it. So agent first sense the dirt in the room, and then it will perform the action. Perceptions. A percept is the input that an intelligent agent is receiving at any given moment. For example, agent came into room, or you put an the vacuum cleaner in the room. And the first thing which come to agent as an input is, okay, there is some kind of dirt in the room. This is known as the percept. We use the term percept to refer to the agent perceptual inputs at any given instant. An agent's percept sequence is the complete history of everything the agent has ever perceived. So what is the percept sequence of the agent is, okay, agent saw initially the room is clean, it is not doing anything. After some time, there is some dirt in the room. Agent sense it and it will take action. That's the second thing. Again, the agent saw everything, sense it, okay, the room is clean, so it will do nothing. And like this will carry on. Whenever it saw something, it will clean it. And if it does not saw something, it will not clean it. So this is a kind of sequence, and this is the history of the agent. So this will be stored in the agent history as well, that okay, this time when something was like, we will be using the history in the coming slides, which is another part of the artificial intelligence, which is known as machine learning. So why his history is really important. So you need to know about a bit of it. So agent is like the action or the task performed by the agent by getting some info from the environment. So this is known as the percept sequence. All right, so as I said, the room is dirty, so agent sense it. So that is the first percept agent sense it, right? Now action. Agents, there is some which if agent sense something, you can also call perception sensing the environment. You can in easily term you can call it. If it's hard for you to know the perception, just know that it's the sensors or where the agent sense something in the environment, in its environment. Now agent sense something in its environment, it needs to perform some kind of action. The agent function for an agent specifies the action taken by the agent in response to any percept sequence. So percept sequence, as I told you, the room is clean, the room is dirty, and the room is clean again, the room is dirty. So these things agents have, if agents have done these before, so agents know what is my task next. If it's dirty, clean it. If it's not dirty, don't do anything. So these are the action which the agent will take once it perceives something in the environment. The percept should be a dirty room, or it should be clean room. So in the example here, I just mentioned the room is dirty. It can also be the room is clean, can also be the example of perception, right? So the action is, if the room is dirty, clean the room. If I am taking the example of perception as the room is clean, so my action will be do nothing. My example of the action will be do nothing. So this is just a general representation of the agent and the environment, how it works, or how agent interacts with environment through sensor and actuators. So we are having environment at right side, and then we are having agent at the left side. So agent sense something, a percept come from the environment to agent through sensors, and then through actuators, agent will take some action in the environment. So it is like a kind of cycle here. From environment, the agent is getting percepts, and from the agent, the environment, in the environment, there will be some actions. Well, the question mark here is the function, the agent function, which is we are not going to discuss it here, which is like a really complex term. You just need to understand, okay, how agent perform. It sense the environment, and it perform action in the environment. Now, this thing here, the question mark, is actually the agent function. What we are not going into details of the agent function, but just to give you some idea what the agent function is. So in simple term, the behavior of an agent is known as the agent function. How agent will perform a task, it is known as the agent function. Like mathematically, we are having the agent has done a lot of tasks before. So that is the input of the history of perception, that, okay, we are having this input. If the room was dirty, clean it. If the room was clean, do nothing. These are the input to the agent. So when the agent next time see something, okay, it's dirty, clean it. It's not dirty, don't clean it. So these are the input. The history of perception should be the is going to be the input to the agent function, and output will be to take an action. Practically, it is implemented by agent program. So as you know, as you all know, function are always inside the program. So even you are writing some kind of program, it consists of different functions. So one of the function of the agent is taking action. One of the function of the agent is to sense the environment and take an action, which is implemented by agent program. Like you can say it like agent, a program is an umbrella, and there are like parts inside the agent program, in which one part is the agent function. Agent function is a mathematically function that maps the sequence of perceptions into action. The function is implemented as agent program. The part of the agent taking an action is called actuators. So this is again the same thing which I have explained in the previous slides. But yeah, if like in the first slide, I have given my email address. So if you are having any kind of confusion, please feel free to reach out to me anytime. I will try my best to answer you, and will try to answer as soon as possible. I know this is like, this is not going to be, if this is the first time for you, it's not going to be really easy for you, but still I want you guys to go through it. And if you're having any problem or issues, please feel free to reach out to me. Now we are going to I'm going to give you an example of the agent and the environment. So perceived sequence and action, these are like the input, right? These are going to be the input. Perceived sequence is the input, and action is the output of the agent function. And at the right hand side, you can see in the box A, there is some dirt, which is like the gray circles, and there is an agent. And in the B box, there are just dirt and no agent. So a vacuum cleaner word with just two locations. Now, for example, the perceived sequence, the agent is in box A, and it needs to clean it, right? And if it's clean, once it cleans it, what it will do, okay, this room is clean now, go to the right. No, sorry. Sorry. If the agent is room A and it is clean, so this is the percept of the agent. Its sense is from the environment that, okay, I am in this room and it is clean. I have to do nothing in this room. What I should do, go to the next room, which is B, which is at the right side. So action will be room A is clean, go to the right side. But if room A is dirty, then suck the dirt, right? Suck the dirt. If agent is in room B and it is clean, it will do nothing, but it will go to the left side, which is A box. So if B is clean, agent will do nothing, and it will come to the box A, which is at the left side. But if agent is in the room B, in the box B, and if it's dirty, it will suck it. By suck it means it will clean it. Also, if agent is in, there is a kind of possibility of the loops that, okay, the agent is in room A and it is clean. So after some time, before going somewhere else, they didn't send something again, but like say, okay, it's clean, nothing is here. If it's performed, it sends something, but the room is clean, it will still do nothing. So it will go to the right side. So these two terms, the same terms, mean like, okay, agent, there will be kind of loop that agent will sense after some time. So in the next thing, if you see here, agent is in room A and it's clean, but after some time, agent is still in room A and the room became dirty, then it will clean it. Again, it's like it will sense again and again and again, and If it's clean, it will do nothing. It will go to the right side until it's dirty. Otherwise, if it's dirty, it will suck it. It will clean the environment. So this is like a really basic example to understand agent and the environment, right? So our agent is and the environment is A and B box. Our agent is the vacuum cleaner, and percept sequence are the input, or you can say agent sense these things: clean, dirty, agent. These are done by the agent sensors, and by performing the action, right, suck or left, this is done by the actuators of the agent. So the four terms which we defined previously are explained, or in this example, really quite good. Subset of artificial intelligence. Till now, we have learned about what AI is, and now we will learn about various subsets of AI. Following are the most common subsets of AI. So AI is divided. AI is quite a big field. It's not just a small thing where agent is performing its task. No. AI is really a big thing. We have divided into several parts. One of them is machine learning, deep learning, and robotics. So machine learning and deep learning, robotics, all of the three fields are quite interesting and like working and helping us a lot nowadays in every field of our life. So now we will discuss each one of them one by one in detail, okay? So what is machine learning? Machine learning is about learning, reasoning, and acting based on data, right? It is one of the today's most rapidly growing technical field, lying at the intersection of computer science and statistics, and at the core of artificial intelligence and data science. So, in simple terms, what machine learning is, you are having some historical data. And you want to predict something, what is going to be my next step, like you want to predict some kind of future events. So you use the historical data, and you will have some kind of model, and you are having historical data by applying you will make from on that data, you will run on some kind of algorithms which will make a kind of model for you. So then that model can be used for prediction, which we are going to see very soon here. So it's all about machine learn from the historical data, and it gives you the results of the future. Okay, so here it is. Machine learning is also divided into three subtypes. One is supervised learning, one is reinforcement learning, and the one is unsupervised learning. So what is supervised learning? Supervised learning, we are having historical data, they are labeled. For now, just understand this basic difference here. We will go into depth in the coming slides here. All right, so when the data is labeled, we use the machine learning techniques known as supervised learning. When the data is not labeled, then we use unsupervised learning. And when there is no data, you have started at some point and there is no historical data, and the agent is performing a task by just observing things, and there is no historical data for agent to act upon it, to get the pattern from the data. Okay, previously I did this thing, so now I need to do this thing. But if it's not available, then the agent will perform by itself by observing things. So that is known as reinforcement learning. So in supervised learning, the data is labeled. In unsupervised learning, the data is not labeled. In reinforcement learning, there is no data. The agent will learn by itself at runtime. supervised machine learning. What is a model? As I told you before that we made some models from the historical data which give us prediction, future predictions. So now what is actually a model? A model represents what was learned by machine learning algorithm, right? We put data into machine learning algorithm and we create models, and that model help us in predictions. The model is a thing that is saved after running a machine learning algorithm on training data and represent the rules, numbers, and any other algorithm specific data structure required to make prediction. Yeah, it's quite simple. What we do, we are having, for example, we are having a lot of historical data. We have some kind of machine learning algorithms. We put all those historical data into the machine learning algorithms, and it will give us a model. Machine learning, the output of the machine learning algorithm will be a model, and that model we will give it the future. We will give it a data, like we will give the data to a model, and it will predict, okay, this should be the answer of this future event. So I will, for example, a really good example I have for this supervised machine learning here. We are having a lot of everybody loves to hear songs, so you are having a playlist of your own in your phone, in your mobile phone, and there is also a button like a heart shape where you liked or unliked the song. So when you are liking a lot of when you are listening to songs, then some of the songs you liked or you dislike, and dislike is, the labeling of data. You labeled it. Okay, I like this one and I don't like this one. So what you did, you were having a list of songs, which is our data, and you labeled it. You like it and you didn't like it. So this is labeled on the data, right? Now, we are having machine learning algorithms. We will be seeing a few of, we have a lot, but we will be seeing 2 or 3 in the coming slides. So you will give their labeled data to the algorithms, machine learning algorithms, and then if you give another songs to that model, when you give the data, the labeled data to the machine learning algorithm, it will create a model, right? Then when there is a song which you are about to hear for the first time, and if you give that song to the model, so by observing the previous pattern, by observing patterns in the previous data, okay, this song is of this is the category of the song. This is sung by this singer, and it was, what is the length of the song, what is the pitch of whatever it is, and it is liked by this person, the user. So the upcoming song is exactly the same as this one, the one which was included in our historical data. So the new song is also the user is also going to like the comings to the new song. So this is how it works. This is supervised machine learning, just because you labeled the data. So we are having a lot of models of supervised learning. So it's like linear regression and a neural network model. So we will be discussing these two in detail. All right, so no model is perfect, but some are useful. Remember this term that we are using model for predictions. So that model, not even a single model in 100% perfect. Even if give you the perfect, if it give you the correct result, but it is a prediction which can't be perfect. It helps us just in prediction. Okay, supervised machine learning method for automatically learning a model for the relationship between input and output. So supervised machine learning, we are having input is our label data, and it will give us our output, which is y from the observed training data. Remember, observed training data means that we have the training data have been observed, and have been, by observed here it means labeled, right? So in machine learning, you give this is just a simple representation of how the models work here. You just give the input to the model, and the model will give you output from the observed training data. Regression and classification. These are the two examples of supervised machine learning. Regression is when the output Y is quantitative. So we are having two types of mathematical terms, quantitative and qualitative. So when it is quantitative, then it's going to be regression. When the output is quantitative, we are going to be use regression, and if it's qualitative, then it's going to be classification. So more details coming soon. All right, so climate model, if like, increase in the global temperature, we are predicting Y, which Y is like increase in the global temperature. So we know that it's kind of quantitative, right? Not qualitative. So degradation of soil quality or increase in the global temperature, we are going to find out these things. So what we will do, we will use regression models. This is another example, like socio-economic models, where change in GDP, we need to find happiness, and these two are connected. So if we know like what is the type of the output, according to that thing, we are going to use our models. So regression is normally used for quantitative outputs. So here you can see that change in GDP, happiness, and increase in global temperature, degradation of soil quality. These are all quantitative, not qualitative. This is another example of the regression social media engagement. Now classification, when the output is qualitative, when we know that okay, what we are going to find out, the output is going to be qualitative, then we are going to use classification. For example, we are having emails are coming to our inbox, right? And we are having two types of email. It's a good email, it's a spam email, right? So the model which we are going to use it for is the classification model. So it will classify the email according to good email and spam email by looking into the pattern inside the email. By the pattern, I mean the content. If like, what are normally the spam emails are, when you got an email from someone, okay, you have won this amount of money. So obviously these are spam. So machine learning models no such thing before, because they have been trained on the previous data. So in the previous data, when there was such content, like such lines that you have won this thing and it was labeled this is spam, so in the future when there's a new email and in the email it is mentioned you have won this amount of data, it will directly send it to the spam folder. So this is done by classification model. Okay, diagnosis system. This is like you are having your reports, you are not feeling well, and your reports came like after you were scanning or everything, you go to doctor and the report came, and then they will decide it looking into your report. So the model will decide it, okay, if you are having what kind of diseases, AML or CLL, these are like medical terms. So this is also done by classification, because you are classifying things here. You are classifying the diseases here. So fingerprint verification, match and no match, as like what's going to be the output of the printing machine. Okay, it matched or it not matched. So this is qualitative, not quantitative. So for such thing we are also using classification models. Game win and lose. All right. So now, in summary, in short, you know that now regression is we are using a regression model when the output is quantitative, but we are using classification when the output is qualitative. And obviously, you don't know the actual output value, but you know the type of the output. So quantitative and qualitative is the type of the output. So from the type of the output, you can simply use regression or a classification. So in the regression model, it is as I have said previously, like input and output data, that was for general, but here in regression, what you do, you give input data to the model and it produces some prediction, which is our Y. regression, learning a model explaining y from x. So like y is our output, explaining output from the input data, and input here is x when y is numerical. So the basic formula for regression is output, which is y is equal to function of x beta plus noise. So remember, there will always be noise. A noise is like this is data which is different. Like noise will be a really small amount of noise in a data, which means that there are some points in the data which deviates from the actual or the average data. So for example, I will show you in the coming graph that which one point or data behave like noise. So we need to add the data as well to the model so that we can get accurate model, right? To the algorithm so that we can get accurate models. Beta are the parameters of the model. Beta is anything. Consider it for now. Consider it just a constant here. It can be anything. It depends upon the data. So it can be anything. For the important thing here is the input x and the noise in the data, which is also in the x. So we need to, if we want a good model, we need to remove the noise. We need to reduce the noise, right? So it's like plus noise, but the noise will always be negative. So you will addition and subtraction is equal to subtraction. So it will always be subtracted from this term. Now, here's the regression example of car stopping distances. At the bottom, you can see horizontally, we are measuring the speed, and vertically, we are measuring the distance. And the data show that at this speed and it covered this much distance, and then like we applied brake, right? So this is by this thing, this is like the historical data that we have said with ourselves. Now we want to predict something. Okay, at how much speed, how much distance we can cover, right? So we need to give this whole data to our model to predict our predictions. Like if I say, my input to the model is, okay, if I am running at 35 speed here, so how much distance I can cover? Or if I say, if I covered 100 feet of distance, what is my speed? So this is going to be the prediction by the model now, right? So all these black dots are our data, and we are giving these data to our model, and the model, after we have the model ready, we will give an input, which is our x, and the model will give us output, which is our y. All right, here we are using this model now, and this model is made or generated from these data. If you see these, like the curve is exactly showing the behavior of the data, the observed data. These are the observed data, right? Not these are the observed. Remember, the black dots are the observed data, not the input data. The input data is going, we are giving the input data soon to them, the input data will be if we are giving something related to speed or distance to the model, and it will predict something. So that will be our input data. The black dots are the observed data. Please keep this in mind. These are the observed data. We made models from the observed data, and we will give an input to this model, and it will give us output. All right, so now, for example, we give the model that we are going at 32.5 speed. This is the speed of the car. How much distance it should cover? So you can see this. If this is our point, this is the speed here. So it will tell you that, okay, here you will most probably cover 75 or between 75 and 80 feet distance the car will cover with this much speed. And if this is our speed is 45, 45, then you will cover more than 100. Or if you say, if I am covering more than 100, so you are going with speed more than 45 mph. So prediction is y is here our prediction, and x is here. X is our input to the model here, right? So you can have many models. It's not like you are just going to have one model. You can have, by observing the data, you can have a lot of models. It depends which kind of model you are making. If you see here, this model fits the data, the best one. And so this model is, this is not linear. This is a regression. This is, linear regression. And there's another one is algorithmic regression. You can say this is showing like kind of exponential. So this is not linear. But here in this graph, we use a linear model. So it's totally up to you what kind of model you want to make from the observed data. So you can make a lot of models by observing the data, but you need to give the type of the model. Okay, which type of model I need here? So if I need linear regression, then I will mention it. Okay, please make a model which is linear from the observed data. And if I need non-linear, then I will mention like logarithmic or exponential model I need. So just mention it that I need logarithmic or exponential model from the observed data. But here we are using linear regression for our machine learning technique. So this is our linear model, and we do the prediction here. So we can have other model as well. If you see, like these different colors represent different kind of models. But obviously, as I said, we choose the best model. So if you see this one line, the green line, which is totally opposite to our data, this is not, and it's, you can see it's like kind of behaving in opposite direction. So this is totally not a good model. But in these three, these are like similar to each other. So these can work better than this one, the fourth linear regression model, right? Now classification, it's the same thing almost, but remember that our output will be categorical, not quantitative. So you give input variable to the model, and the model will give you the output variable y. So here, I'm sorry, here's a small mistake, regression, but this is classification. This is not a regression here in the slide, right? So learning a model explaining y from x when y is categorical. So again, if this function is our model, we give it an input x, right? And the beta is, it's also like, as I showed you, it's something related to the data. Normally when you will work with machine learning algorithm, then you calculate it normally, but for now just ignore it. So I should have not mentioned it here. It's not that important now. So you give function to the you give input x to the function is our model, and we also add noise, the noise in the data, like some of the points in the graph, which okay, I haven't shown you. I'm going back to it in a while. So this is the model. You give some input to the model and plus some noise, and the model will give you the answer of the whole thing will be our output here. So example, a model used to classify the songs. As I told you, if we are doing classification, we are categorizing the data. I like this one song, I don't like this one song, then we use classification. For example, if you see here, this black dots, these two black dots are really away from the other data, if you see. But what if I'm having a point over here, that is like really away from the other data, right? So I consider that point as a noise in the graph. And that noise point, what actually it do, if that is the part of my observed data, and I am making my model on a data which contain a lot of noises, it will give me a really bad model. So what I will do before making a model, I need to clean the data by removing the noise. Or you can simply do it when you have a model. You just by creating with the data observed which contain noises, And when you give the input to the model, just subtract that point, which is the noise, from the result of the model. So it will be the same when it will be the same when you remove the noise before making the model. Before making the model, it will give you the same answer, the same results or output. Okay, so now we are seeing some example of the numerical and categorical variables here. So okay, so here's already you can see it's like numerical and 17.31 kg or something. If there's measurement, it's always numerical measurement, you know, it's always numerical. But if you see brown hair, red hair, and blonde hair, this is categorical data. So for numerical, we will be using a regression, and for categorical, we will be using classification. So again, so this is genuine, cytosine, thymine, adenine. These are categorical. So we will be using classification model if we are to find out something of these categories. So we will be using classification model. Again, numerical data, we will be using the regression here. So categorical output variable is equal to classification, as discussed previously. Workflow. How machine learning works. First, ask the right questions mean what we are going to do with the machine learning. First, formulate the problem as a machine learning problem. Okay, if I am making a model, I'm having this data, as I told you, by looking at the data, and you know what output I needs, right? What output I needs, is this going to be categorical output, or is going to be the numerical output? So then you will define, looking at the data, you will formulate the problem as machine learning problem. Okay, I am going with it. This is the data. This should be my output. Then which means that you formulate the problem as machine learning problem. Collect the training data, right? So as much possible as you have training data, the model is going to be strong, right? If you are having less data, the model will not be as strong as when you have like a lot of data. So when you have data and you formulate the problem as a machine learning problem, then you need try to collect as much data as possible to make your model strong. Then you need to pre-process the data. As I told you, remove unwanted things, noise from the data. We don't need that thing, just because it's always affect our models. So you need to pre-process the data. Choose which model to use. Now, we have already decided, okay, this should be our output. Now, as I told you, in linear regression, in regression model, you are having different kind of regression model. So which one model you are going to choose? Linear regression model or logistic regression model or some kind of other thing? So this is up to you now, but you know we are going to use regression just because the output is going to be numerical. So then you need to decide, after the pre-processing data, you need to decide which model to choose. Then you will learn, train, estimate, fit the model from the training data, right? You will train the model according you will train the model by having the data, observed data available to you. Now fix X into the model. This X is our input, right? We have model, we make the model by using our training data. Now what you will do, we will feed X into the model, which is our input. And now considering that input, the model will give us a prediction Y. All right, so when the model give you the prediction, but this is the prediction, you can't be sure how much it's correct or not correct. So then there are different evaluating techniques which you use to check, okay, this model is correct or this model is not correct. So which is not like the part of this course now, but you always evaluate your model. So if there's like kind of threshold, if it is like the model is working 80%, like it's giving 20% error, or that's fine. But if it is like giving more than 20% error, we should not choose that model, because it's not a really good model. So you always evaluate your prediction, or you like there are some kind of methods which we call cross validation, or there are another techniques where you compare the same model on another kind of data. But so when you observe that, okay, this model is the same model is behaving for different inputs, and you know, like as we know that in supervised machine learning, the data is labeled, so we know that the we know the actual output. But we in supervised machine learning, we actually want to check if this model is performing well or not. So there are different kinds of models or methods where you evaluate your machine learning model, if it's performing good or it's not performing good. So here, to summarize the concept, machine learning deals with learning, reasoning, and acting based on the data. Regression problems where the output is quantitative, and in classification, it's going to be qualitative or categorical, or regression quantitative, you can also say numerical. Training data is the data set that is used to learn a model from the data, right? So we normally use training data set, which is our observed data, and we use it to learn our model from the data. And yes, remember one thing, as I told you, that here in the previous slide, in the last step, evaluation of the data, just because we made the model by from the observed data, you are never gonna use the same data from which the model is made in evaluation, okay? Because it will be 100% correct then. Now, unsupervised machine learning, another really interesting topic. This is the part of AI, sub-part of AI, where the data is not labeled. So the use of artificial intelligence AI system to find patterns in data set, including data points that are neither categorized nor labeled, is known as supervised machine learning. So for example, now you are giving some data to a model, and the data is not labeled. So there are another techniques to do machine learning when the data is not labeled. Like there is a list of songs where you didn't put like and dislike in front of each song. So for such data set, we are using supervised machine learning. Unsupervised learning, in other terms, allow the system to recognize pattern in the data sets on its own. So in supervised machine learning, the model know that by looking, the model can easily predict by looking at the label and at the label of the data. But here, the model will try to learn the pattern by itself. So the prediction here will be more dependent on the machine, more like it's responsibility of the machine to give you the exact result without knowing that, okay, is it what the actual result should be. By actual result, I mean that what the model don't know exactly what is this label, what is the label, is this data labeled or not. Sorry, I'm a bit confused here. Sorry, no, it is like in here in the machine learning, in unsupervised machine learning, we are providing the data which is unlabeled, right? So what the model will do, it will try to recognize some kind of patterns in the data provided, and then it will give you the prediction. So we will see in the coming slides soon how unsupervised machine learning work in an example. So unsupervised learning can be classified into two categories of algorithm: clustering and association rule mining. So we are having data, and the data is not labeled, so the machine can't predict it easily. So what will unsupervised machine learning do? There are two techniques to do the predictions here: by clustering and by association rule mining. Okay, what is clustering? Classification is a supervised data mining task. As I previously explained, regression and classification is a supervised data mining task. Supervised mean that we are providing the system algorithm the wanted solution expressed in a class attribute. By wanted solution mean the data is already labeled, right? And we just give it to the model. But clustering is unsupervised. The algorithm must figure out how to group the data. So now we are having the data without labels. So the algorithm will make categories, will make clusters of the data of the which is similar to each other. So if I give the example, like when you are having a list of songs, so what and that are not like and dislike. So first of all, what the unsupervised machine learning model, what it will do, it will try to make clusters by, for example, if the clustering point is singer, right? So it will make clusters by singer. Okay, this singer's song, this many songs, it is in your playlist, so it will make clusters according to that. Finding groups of object, such as the object in a group will be similar, related to each other, to similar to one another and different from the objects in another group. So for example, we are having a lot of data, unlabeled data, and when it is categorized by the clusters, when we do clustering here, so when we do clustering here, we got like, we are having unlabeled data, and the algorithms, unsupervised machine learning algorithm create 3 clusters by finding out the patterns. So this is a kind of black box. You don't know how it did it, but it did it by looking at different features. You know, data having features. So if we have one song, so it have different kind of features. For example, the singer name, and what is the genre of the song, what is the duration, what is the pitch, and other stuff, right? So these are the feature of the song. So by looking at the feature of the songs, data is classified. Like song is just an example. So unlabeled data is classified here. By classified I mean clustered here into three clusters. But remember that the data inside each clusters are similar to each other, right? These are intra-cluster distances are minimized. So the distance between the data in each cluster, they are minimized, but the distance between the data of one cluster to the distance between the data in another cluster is maximized, so that it can easily be differentiated. Okay, this is one cluster, this is another cluster, right? And a set of a cluster is called clustering. So this is one cluster, this is another cluster, this is another cluster. So these three is known as clustering. We did clustering here. Now clustering, we are having one method to do clustering, and which is known as k-mean clustering. In k-mean clustering, how we do clustering, actually, we measure the distance between points, right? So now here you can see partitional clustering approach. We do partitions, right? And each cluster is associated with a centroid, center point. Yes, this X is the centroid. Each point is assigned to the cluster with the closest centroids. All right. I'm going to explain it in the diagram below. Number of cluster must be specified. The basic algorithm is very simple. Yeah. All right. Here. So now we are going to do clustering, but we are using which method for clustering? K-mean clustering. So we are having unlabeled data. This is our unlabeled data. This gray thing. Okay. What we will do? All right. To do clustering, to do clustering by k-means, you always need to specify how many clusters I need, right? How many clusters you need? That is k. You must give the instruction that I need 3 clusters, right? I want this data to be divided into 3 clusters. So if you see, this is I put one cross here in this area, and one in this area, and one in this area. Now then I will find out the distance of each point in this unlabeled data to every single point, which is a number of clusters, which is the centroid. You know, as I mentioned here, the centroid. I will find the distance of each unlabeled data to the 3, where I choose K3, which is of my centroid, to the centroid, and I will categorize it, the point which having like the minimum distance to the centroid. I will give it I will make it a cluster. So the point, this centroid, for example, if you say this cross is one of my centroid, so all the data which is near to this centroid, which means that the distance from the point to the centroid is minimum, what I give it, like this is my one cluster, this is my another cluster the same, and this is my third cluster. But remember, if I check this, this is my point, and if I measure the distance between this point and this one centroid, which is much bigger as compared to this one, right? So what I do, I simply assign this data to the nearest centroid. So this is how you do clustering. Now, association rule mining. What is association rule mining? But before going to the explanation, I want to define some basics definition which we are going to use in the association rule mining definition. Item set, a collection of one or more items. For example, milk, bread, diaper. This is a set, right? You know set. This is a set which is closed inside braces. So item set is a collection of one or more items. K item set means the number of items in one set. So an item set that contains K items. So this is my one item, this is my two items, this is my three items. So this is actually 3 item sets, right? So K is a general term used for the numbers. Support count. Frequency of n item sets. For example, we are having a lot of transaction. We are having a table, and we need to find out the transaction of milk, bread, and diaper combined in the whole table. So in one transaction, we buy milk, diaper, and bread, and some other stuff, but these were included. And there is another transaction as well where with other stuff, milk, bread, and diaper was included. So that is support, how we counted. There is an example of how to count this. It's coming. Support fraction of transaction that contain an item sets. This thing will be clear now in the coming example as well. Just remember these definitions. Fraction of transactions that contain an item set. For example, we are having 5 transactions, and those 5 transactions contain 2 support count. Like in 5 transactions, 2 of the transaction contain milk, bread, and diaper. So it is 2 by 5, right? This is my support. Frequent item set, an item set whose support is greater than or equal to a minimum. Okay, so we always define a threshold value. If the support count is greater than threshold value, those item sets are known as frequent item sets. For example, if the minimum threshold value is like 3, if I say like the support count should be more than 3, so if the item set like if I say the min sub threshold is 3, then what I say, the support, if all the data, all the items which is having support more than 3, which occur more than 3 times in the transaction, that is my frequent item sets. Any logical calculation done in consistent mode in a database is known as transaction. Transaction is kind of like you are doing a logical calculation. Okay, if I bought this along with this, this term is not very important here. It's just for you understanding. Any logical calculation done in a consistent mood in a database is known as logical transaction. By consistent mean, okay, I am buying this stuff, I'm buying this stuff the other time. If I am buying the same, like the logic is the same, but it is consisting. Okay, I'm just buying, but different things, right? So this is known as transaction. All right, so now association rule. What is association rule? An implication expression of the form X implies Y, where X and Y's are the item set. So now, simple example, what is the rule here now? I am buying milk and diaper, but if I am buying milk and diaper, I'm along with these two, I'm also buying beer. So this is known as association rule mining. If I'm buying these two items set, then I should buy beer as well, right? So this is how association rule is defined. It implies I am buying X, then I should buy Y as well. So this is the table here. You can see TID, these are the transaction. We do this kind of transaction, 5 transaction here. In initial thing, I bought bread and milk only, right? And in the second transaction, I bought bread, diaper, beer, eggs, but I didn't buy diaper here. Sorry, yeah. I didn't bought like milk here, but I bought diapers and beer. But the thing is, to make it an association rule, I should buy milk and diaper. If I am buying milk and diaper, then I should buy beer, right? But here it's not like that. Now here in transaction 3, if you see, I'm buying milk and I'm buying diaper, I am also buying beer. Here if you see, I'm buying milk and diaper and also beer. So what we do normally here, if I am buying milk and diaper, then I also bought beer. But if I'm buying beer and diaper, then I didn't bought milk, right? So my association rule will be like, if you are buying milk and diaper, then you buy beer as well. As there, milk and diaper, then you buy beer as well. But if you're buying beer and diaper, you are, but if you are buying, but if you are buying here, if you are buying beer and diaper, you are not going to buy milk. So the association rule is its implication expression of the form. If you are buying something, which if you are buying something, then you buy another stuff. Rule evaluation matrix. So it's again the same example here. Support as defined previously, fraction of transaction that contain both X and Y, right? If I am buying a diaper and bread, then I should buy beer as well. So sigma is a function which calculate the support. So what is my support? X and Y. X is milk and diaper, and Y is the beer, and divided by total transaction, just because it's the fraction of transaction that contain both X and Y. So how to find the support from this table? You need to check these three must be present in a transaction. So the total number of transactions are 5, 1, 2, 3, 4, 5, right? And now we need to check how many transactions contain milk, beer, and diaper together. So bread, milk, no. Bread, diaper, beer, no. Milk, diaper, beer, yes, 1. In the fourth one, you see milk, diaper, and beer again, so 2. Here we have milk and diaper, but no beer, so no. So these two contain the each of 3 here. So my support will be 2 divided by 5. This is how you calculate support. Now confidence. In the confidence, we are not going to go with the Y thing. We will just be going with the X stuff here, okay? If you are going this 2, so you will, it will become more clear now with the below example here. Measure how often Y appears in transaction that contain X. For example, so if you are in the support, what we were doing, we were doing the total, we were dividing it by the total transaction. But now here in this in the confidence, we will be dividing it by the X term, which is the item sets at the left hand side, right? So measure how often Y appears in transaction that contain X. So the formula is sigma. So how many transactions in this table contain milk, beer, and diaper together, which we find out already. This is the two terms. These two terms contain milk, diaper, and beer. But now, and it is divided by the sigma milk and diaper, which is our X term, right? So milk and diaper together are in how many transaction? This one doesn't contain both diaper, but there is no milk. Milk and diaper, yes. Milk and diaper, yes. Milk and diaper, yes. So the divided, we will be dividing two, like these three are into together in two transaction, and these two are together in three transaction. So it is going to be like 2 by 3. Yeah, so our confidence is 0.67. So by confidence, by finding out the confidence and support, we find out normally the frequent item sets, and there must be a threshold given to, as I have explained previously. There is a frequent item set. You must define a threshold, minimum, min sub threshold. So you have mentioned already that, okay, min sub threshold is 3. So if the support is greater than 3, that item is a frequent item. And if it's not greater than 3, this is not a frequent item set. And the same is with confidence. All right. So association rule mining task. Given a set of transaction, the goal of association rule mining is to find all the rules having support greater or equal to, as I told you, support greater or equal to min sub threshold, confidence greater or equal to min confidence threshold. So you will be giving two threshold values, one for support and one for the confidence, to find out the frequent item sets. So you will have like this is one of the method, like how you will do it. Another one approach is to find the frequent item set, or to cluster, not cluster, I can't say cluster here, but to categorize thing. Okay, these item sets are frequent, so these belong to one place, and the other one is belong to category. You can call it category. Obviously category is not a really good term, but just to make it simple to you, we are classifying things in such a way, right? By support, by giving the threshold values. Now, so what actually we are doing here, we are just finding out the patterns. Remember one thing, we are just finding out the same patterns, that okay, these patterns looks the same in this data, so these data are behaving the same. These are the same data. So we are just finding out the patterns here. So in brute force approach, list all the possible association rules. Like, okay, here I just wrote some of the association rule. You can see this is like, okay, milk and diaper, beer, but you need to make the whole combination, milk, diaper, beer, or beer, diaper, milk, like something. You will do a lot of this is the brute force approach, which is not considered a good one, just because it took a lot of memory and computation type, but still it is a method to do so. It's important for you guys to know. List all possible association rules, right? Compute the support and confidence for each rule. So now you will find out again the support and the confidence for each rule. But like, this is when you don't have anything, we don't know nothing. But if you know that, okay, I just want to know about the beer, the milk, and the bread, so you just simply directly just find out those rules. But when you having data and have no idea, but you need to do the unsupervised learning, so then you will find out the association rule, all of the possible item sets, and then you will compute the support and confidence for each single rule, and then you prune rules that fail. Okay, what you will do then? Okay, you find out the support and the confidence to every association rule. Okay, then you are having two values, right? A minimum sub and minimum confidence. So you will discard all those values which you calculated here. In the second step, you will remove all those points which are having the values less than minimum support and minimum confidence threshold. So this is how association rule mining works. So actually associational mining and clusters, these are unsupervised machine learning algorithm techniques. So what is the purpose of our, machine learning thing is to give us the prediction. So by using clustering here, when we divided the data, when we divided the data in cluster in 3 classes, here this is unlabeled data, and we label and we made clusters here. So if we are having another data is coming which is new to the whole thing, and for example, if the data comes to this point at here in the green box, so we will find out the distance between that point to each of the centroid, and will assign it to the cluster to a cluster where it is having the minimum distance to a centroid. So if it is in this area, we automatically consider it to the part of this cluster. So this is how you do the prediction, right? And simple in associational mining, okay, if I am buying bread and milk, then I should buy beer as well. So if I'm buying diaper, and milk, then I should buy a beer. The person, like if you're having the previous data where in the table there is like a lot of people bought milk, diaper and beer together. So if a new customer is coming to a shop and he's buying milk and diaper, so you will automatically know, okay, the next prediction is he's going to buy the beer as well. So yeah, this is all about unsupervised machine learning. Now I'm going to explain reinforcement learning in a while, but before that, I think we should have a small break. So welcome back. So now reinforcement learning, as I have told you before, in reinforcement learning, we don't have any data, right? And the action will work on rewards here. What we do here, we say the agent, okay, if you take these steps, we will give you 1 point. And if you go to the wrong side, you will get -1 point. So agent will always try to increase its reward, right? So it will not work on the data, it will just work on the reward. So reinforcement learning is a method of learning in which an agent is taught by issuing orders and receiving a reward as a result of each action. So here, agent don't know what it's going to do. So we will assign some kind of rewards to the agent that, okay, you don't have any data, you don't need, we have not given any instruction to the agent what is going to do. So, but agents know that I have to perform some action, but what action he actually don't know. So when he is in a room and he do nothing, and he is in a dirty room, as shown in the diagram below, he is in a dirty room and he is sensing something. He sensed something and he did not, he did nothing. He stand there and he sensed something, he did nothing, he got -1 point. But when he sensed something and he clean it, it will go to +1 point. So now agent know that if I clean something, I will get 1 point. But if I don't clean something and I sense, I use my powers, then it will give me -1. It is decreasing my rewards. So it's not like it will do a lot of, it will take some time for agent to understand that cleaning will give you a reward, but not cleaning a dirty room will decrease your reward. So like if it will take like maybe 2 minutes or 3 minutes for agent to train itself, like, okay, cleaning giving reward and not cleaning giving not reward. So yeah, when agent get a reward by cleaning it, then the room is clean. But agent don't have any previous data, but agent can perform its action, right? Just because that is what agent is supposed to do. Agent will go to room B, right? Then, and he knows that, okay, cleaning will give me a reward, then it will clean it. So this is how agent learns, by rewards. Okay, this and agent also know that I'm doing nothing and it is decreasing my reward. So it will always try to move around and to clean the room. Also, that as I told you, the agent perform action. The action cleaning is if the agent clean the room, it will give a reward. But if the agent is moving to the left side of the room, which is nothing, so which means that agent perform action, but it did nothing, so it will decrease the amount. But when agents move to the left side, so it changes its location. So now the agents also know that cleaning is giving me a reward, net cleaning is not giving me a reward. He also knows that if I am in room A, going to the left side, there is nothing. But if I am in room A and going to the B, to the right side, there is room B. So by these things, by searching and by performing their action, the agents know they came to know the environment, and this is how reinforcement learning do. So the agent performance increasing as the result of these feedbacks. So these are kind of feedbacks for the agent that, okay, to the left of the room A, there is nothing, right? So these are feedbacks to the agent to itself. Reverse feedback can be positive or negative. As I told you, it can be, if it's go to the reward is like if going to the left side of A, but there's nothing, it perform action, so it will decrease its chances. And yeah, this is the example of a simple vacuum cleaner in reinforcement learning, where the agents know nothing initially, and we just left the agent, but we know the agent, we have programmed the agent that these are your action, you can clean, you can move around, and you can sense, right? So these are the edge, this is what agent know. But agent doesn't know that what I need to clean and where I have to go. So if the agent clean dirt, but in the room there's a bed, but we don't assign a reward to it. So if the agent is trying to to suck the bed, there's nothing, it can't do anything, so it will never do it again. And if it's get nothing from that, and or either you can say if it's get a perform an action and did nothing, the bed is really big to suck it, right? So we assign, okay, the agent is going to get -1 reward for it, so the agent will never do it again. This is how reinforcement learning is working. Reinforcement learning itself is quite a big field, which is not like, I can't explain it here in this course. You just need to know about the basic concept of the reinforcement learning. It's like a really advanced term in machine learning, or you can say artificial intelligence. But what you just need to know, okay, this is the term in machine learning, and along with supervised machine learning and unsupervised machine learning, there's another method known as reinforcement learning, where there is no data or no knowledge or no history to agent, and we left agent in an ideal state, and it perform action by action it make its own history, and then by looking into its own history which he created, he performing other tasks. Now, deep learning. Deep learning is also a part of machine learning method, but based on artificial neural networks with representation learning. Now, in the other thing, in the previous task, what we did in supervised machine learning and unsupervised machine learning, our main task was to predict, right? But here in deep learning, what we do, we actually want the machine to learn more. And this is done with the help of neural network. But these learning can be supervised, can be semi-supervised and unsupervised. So here is another term I want to let you know about. The semi-supervised mean where the data is, some data is labeled and some data is not labeled. Those are known as semi-supervised data, right? Or when we are using a method, there are some kind of methods where the data is, some data is labeled and some is not labeled, but we use it. But those methods are known as semi-supervised machine learning. So it's a kind of, I didn't put it in the previous slide just because it is the combination of supervised and unsupervised learning. So now we want the machine to learn by using artificial neural network. This is known as deep learning. Deep learning algorithms are built in a hierarchy of increasing complexity and abstraction. What does this mean? Deep learning, when the data is increasing or when we are giving it a lot of data to learn, so the complexity of this neural network, the model, we can call it the model as well, is going to increase as well as the abstraction. So a lot of data, and if we are having a lot of data and we want our model to learn, and we need to do deep learning to learn a machine, to make a model which should to make a model which should learn a lot from that data, the complexity and the abstraction of the data model will also increase. So I will tell you what does it mean with the example in the next slides. Unlike typical machine learning algorithms, which are linear, so normally machine learning algorithms are linear and non-linear, but artificial neural network will always be non-linear. These are always non-linear, but the good thing is we can do classification, which is a linear problem, right? And linear regression using neural network as well. What we did, we know that neural networks are non-linear programs or methods. We put some kind of function at the end of the neural network which make it linear. Artificial neural network is an example of the deep learning. So artificial neural network are computing systems inspired by biological neural network that constitute animal brains. So the idea of artificial neural network came from human being or the animal brain, where we are having neurons and they're connected to each others. So the same is here in the artificial neural network. Each node or each neural network node, you can call it like maybe I don't know exactly the same term to use for that, but I think it's node. Yeah, it's node. Every node is connected to every other nodes. It's a really complex system, right? So it is made exactly the same as the human brain neurons are connected to each other. An artificial neural network is based on collection of connected unit. Look here, it's mentioned, it's nodes. Connected units or nodes called artificial neurons. So here, the neuron or the nodes in the artificial neural network are known as artificial neurons, which loosely model the neuron in a biological name. So it's just like the comparison to it, but we call those neurons in the artificial neural network as artificial neurons. These are not the natural neurons. So these are designed by programming computers to behave simply like interconnected black cells. Yeah. So these are programmed. The neurons are programmed in such a way which behaves like the neurons in the human cells. So here's the example. I'm gonna the complexity and the abstraction. I'm gonna explain it here. I will tell you here right now. So this is our neural network. It consists of the following layers: input layer. This layer, we input our data here into this layer, right? Then the hidden layers with information get processed. Then these input layers are connected to this hidden layer, and this hidden layer is connected to this. And if you can see this, this node in this, the first hidden layer is connected to every point in the next one, and this connected to this node in the second hidden layer is connected to each point in the third hidden layer, and so on. This is just a really simple example, but it's in actual reality, it's a more complex. There are a lot of, like in the first hidden layer, there are a lot of other layers, which is known as a convolutional neural network, which is the actual deep learning neural network. But this is just the abstract, a small one. I'm just showing it to you. So a lot of data, if I'm having a lot of input data, then a lot of hidden layers will be here, right? So each will be connected to every other neutron. So which means the abstraction is going to be like, there will be a lot. This is just abstracted, a simple thing. So there will be a lot of the thing, and a lot of other nodes will be here which are connected to each other, which means if they are connected to each other, the complexity of the network is also be really hard to understand what it's doing. But the thing is, most of the people, they're using neural network. They don't have nothing to do with these, the inside, the hidden layers. They just give the input and use this output directly. They don't know what is happening inside this black box. But there are obviously methods known as backpropagation to actually look into this, but you don't need to look into it. You just need your result by giving the input things. So now, if you are having a lot of input data, there will be a lot of others hidden layers, and in hidden layers there will be sub layers as well, which means the abstraction and the complexity of the network will increase as the data from which we want to learn increases. Now, another artificial intelligence subcategory is robotics. This is like one of the best, or one of the interesting field in artificial intelligence. So we know a robot is actually a machine, especially one programmed by the computer, capable of carrying out complex series of action automatically. So we program a robot, and it, according to that program, actually the second point actually means that we program our robot in such a way that we have told him, okay, you need to do this, you need to do this, and it's perform all those tasks which we ask him to do. And we also gave him some condition, okay, if it's raining, don't go outside, it will never go outside. So this is what it means, that the robot perform will perform according to what instructions have been set in its program by the programmer. A robot can be guided by external control device, or control may be embedded within. So, for example, a robot can be controlled within by maybe embedded within means like the program inside the system of the robots, which is already there, that control the robot, fine. Now there are like external control devices, mean you are having the remote, you can control it from your remote. Like, for example, you are having if you have a small robot and the cleaning, you can see the cleaning robot, if it's cleaning something, so it's already there in the instruction that, okay, there's dirt in the room, clean it. So that is something embedded inside the robot, right? But there is also control by the remote, like the owner have the remote to make it start working. So a robot can be controlled by external control device, a remote, or maybe embedded system, like and maybe controlled, the control may be embedded within, means like if there is no dirt, so it will stop by itself. But we are interested in intelligent robots. Intelligent robots mean, okay, you have given him few instruction, by using those few instruction, it start utilizing its own instruction, it start learning by its own, by using those few instruction given by the owner. So those are known as intelligent robots. A robot that function as an intelligent machine, that is, it can be programmed to take action and make choices based on the input from the senses. So as discussed previously, these are all connected to each other, these robotics and reinforcement learning or machine learning. These are these terms, when you are going in depth, yeah, they are having different methods. They are divided on the basis of data, but their work, somewhere they will combine. You will use like all of the terminologies like supervised, semi-supervised reinforcement learning, and like data mining. You use it together in some kind of stuff. So these are all interconnected terms to each other. So we use our machine learning techniques to make robotics intelligent. So robot that function an intelligent machine as an intelligent machine, that is, it can be programmed to take action and make choices based on the input from sensors. So for example, as we studied in the previous slide, we give some kind of reward to the agent, to the robot, that, okay, if you are giving it, if you are gonna clean it, then you will get a reward. So it learns from that experience, from that, and they contain that that store that information as a history. So next time when there is dirt, it will look into his history. Okay, there was dirt, I cleaned it, so it will clean it again and get a reward. Again, example, vacuum cleaner or cars without drivers and more. Sophia. Sophia is the most intelligent robot in the world. Sophia is a social humanoid robot developed by Hong Kong-based company Hanson Robotics. And this is really, really intelligent robot which achieved the nationality of Saudi Arabia. Yeah, Hanson designed Sophia to be a suitable companion for the elderly at nursing homes to help crowds at large event or parks. So what was the purpose of the Sophia? The main purpose of the Sophia was to have the older people who are living in nursing houses, and also to the people who are like who need help in a crowd area. Like if you see in China, there are like when you go to a metro station, there's a lot of crowd, and if you are new in China, it's going to be really hard for you to know what you need to do. So like, you know, this is why such robots are developed to help people who needs to know what to do. All right, so the owner said that he hopes that the robots can ultimately interact with other humans sufficiently to gain social skills. So also, Sophia is not just helping people, old people or the people in crowd, the new people in crowd, but it's also talking to different people, to the older people, and you know, getting knowledge from them and making itself more intelligent. Computer vision, again, when computer uses different techniques of as we discussed previously, like artificial intelligence or machine learning or reinforcement learning or even robotics. So and use it for the betterment of for persons, or make things easier for persons for identification or figuring out things. So these things are known as computer visions. A field of artificial intelligence that enable computers and systems to derive meaningful information from digital images, videos, and other visual inputs, and take action or make recommendation based on that information. So again, it's like the same thing as you know, we use classification. If you see in the first image, this is the image, these are some kind of okay, these are trees, apple trees. So what computer do when you open the software or application in your phone and you take a picture, so it identifies, okay, this is apple. So this is like there are a lot of other stuff with apples, like leaves, sky, everything. But what we are interested, it is the classification is done directly by the application, and classification is a machine learning techniques. So it shows us, okay, these are the apples, these boxes are the apple, these are similar, these are the apples. Now recently there is like a technique Amazon has created, a computer vision application, which can also, like if there are celebrities are going to a function, so they will identify that, okay, this is human and its name is this is a person and its name is blah blah. So like, you know, even it can also tell you which is the name of the person. So it's more intelligent now. So this is how like different artificial intelligence techniques are combined to identify stuff and to let you know to take actions. For example, this is you can see in the bottom at the picture at the bottom at right side here, this one. This is the robot identifies, okay, these are the tomatoes, and we need it's already arrived, and if we leave it more for some days, it's going to be like, these are already in good shape, it's going to be rotten then, so we need to remove it. So you know, this is how computer vision work. First it classify, okay, these are tomatoes, then it's classified, okay, it's healthy or it's not rotten, it's like ripe fully and it's not rotten. But if I left it for more days, so it's going to be in bad condition then, so it will take the action, it will take the decision that it's time for me to remove it, so it remove it from the tree. Computer visions in cars. So nowadays it's more common in cars. Manufacturers like Tesla, BMW, Audi, or Volvo, etc. They are using cameras. They are using cameras to let you know for parking purposes. You have back camera. They even decided the length for you. Okay, the distance for you, that okay, you should park now. You don't need to cross this point. So these are like really helping or making life easy for us. So we don't need to damage, or we don't need to collide with other obstacles. So they are using a lot of cameras. They're using for making this thing, or the car, which is more intelligent. They're using cameras, radars, and ultrasonic sensors. So yeah, this is how these identifications are actually, the machine learning techniques. So but these are more like at runtime. You can see, okay, this is the shape, and this like the car shape is already given to the model before. Okay, if something is like this, identify it as a car. If something is like a big thing, more than big thing car, identify it as a truck. So even on the runtime, when you are going, the camera will let you know on the screen. It will tell you that okay, this is car going to the front of you or to the side of you. So this is what computer vision is called. So task, acquire images from the environment so that they take the self-driving car can detect. So yeah, of course, self-driving cars are computer vision is like the main topic related to like we can say self-driving cars are going to use computer vision a lot, because there will be no driver, and it need to be like on track, and it should not cross the light, the signals. So by how it will not cross the signals, it will observe the light in the on the road. So by identifying the lights, okay, these are the lights. Okay, is the light blue, it's on or off? If it's off, stop the car. So this is how computer vision will work a lot, and is working a lot in the car industry right now. So yeah, thank you so much. This is what we all have had for this lecture, and I will really appreciate if you guys, I know this is like a kind of advanced topic, artificial intelligence, but this is the most interesting field in computer science. So if you don't understand a point, or I wish this thing was live and we even on Zoom, so it will be really good if you guys were having some problems, so I should face some of your questions and I answer them on one time. But the thing is, as it's a recorded session, so if you are facing any kind of problem, if you don't understand anything, just please mention the the slide number and send us an email to me, salman.khan@uu.it.se, which is given on the first slide. I will try my best to answer as soon as possible. Thank you so much. Have a good day.